All right, so you can get the other point of intersection by using the same process on your calculator, second, trace, intersect. And then you just have to guess -1 or some number over here to get this. But you also know both of these functions are even, and so this is symmetric about the y-axis. So this point is just -1.265, comma 0.601. All right, so now what do we want to do? Remember, we're trying to find the area in between these two curves. So we are going to integrate from the left to the right. So that would be -1.265 to +1.265, right? And then you're going to take the upper curve, which is the 2 cosine of x, minus the lower curve, which is the x squared minus 1. But remember, you have to use parentheses around the x squared minus 1 because you're subtracting the whole function. All right, so now you're going to integrate that with respect to x. Now, let's think about this. You already had to use your calculator to get the points of intersection, right? Now, you could integrate 2 cosine x. You could integrate the x squared minus 1. But in order to evaluate this, you'd have to use your calculator to plug in the 1.265 and the -1.265 anyway. So what I'm going to do is I'm going to show you how you would calculate this integral using your calculator. All right, so you should have out your calculator again. All right, now you've already graphed the two equations, but now you want to go to your regular calculate screen. All right, so now you're going to go to a button that's called Math, and then you go down to number 9. So this is the numeric integral function. All right, so Math 9. All right, now what you want to do is you want to put in the function that you are integrating, right? So you are integrating 2 cosine x minus x squared minus 1. So you could type in 2 cosine x, close parentheses on the x, minus, and then parentheses, x squared minus 1. Now I'm going to close parentheses on the x squared minus 1. Okay, that's the function. Then I type comma. Okay, now the input has asks for with which variable you're giving respect to. So comma x is the variable, comma now a. So that's the lower limit of integration, 1.265, comma b, the upper limit of integration, 1.265. Okay, and then I close parenthesis on the integral. All right, so now I hit enter, and it calculates my integral of 4.995. So we can say that this area is approximately 4.995. Now, for some of you, if you had a TI-84 that has a newer operating system, or one of the other newer TI calculators, you press Math 9, and it gives you this, with like a little blank here, and a blank here, and then like a blank here, and the blank. So really all you're doing is just kind of filling in the blanks, all right, and then you hit enter. So that one's pretty easy. But when you have the TI-83, you have to fill it in as follows. To find the integral from a to b of f of x dx, you type that in as the finint, and then that is f of x, comma x, comma a, comma b, and then close parentheses on that. All right, so that is slide number 4.